And we are recording now. Welcome to the monthly Python meetup. And I see many of you are still appearing. Very nice. We have a nice turnout. Um, the Python meetup the Austin Python meetup has been becoming more and more global. We had people appearing from all sorts of places in the world every once in a while. Now we're going back locally, or trying to. So it was initially supposed to be a festive meetup in December, but we moved it to November so we can start festivities now. And we're bringing two speakers from local companies, two founders, or actually co-founders of two companies. Um, and they're going to present their companies and some of the work that they're doing. One has to do with packaging, one has to do with machine learning. And let's start and present our presenters. Um, we have Rakshak Talwar from Zenus, it's one local company, and we have Nguyen from Nom Nom. And both of them we're going to present one after the other. We're going to start with Rakshak, who's going to tell us a bit more about machine learning and images, if I recall correctly, correct?
Yes.
Okay.
So there's some echo, I think. Or I think it's gone. Cool. It's Zenus. So it's like that. Okay, cool. I'm gonna go ahead and jump to the presentation. Can you please confirm that you can see this big pink and white screen?
Yes, we see you well.
Awesome. All right, cool. I'm really excited. So my name is Rakshak, and the company is called Zenus. Our company was not born in Austin. It moved to Austin. It's a transplant from Houston, so right down 290. We moved here about April, May, and we really love Austin a lot. Despite it being a pandemic, I still love being here. So I'm going to give a talk on computer vision at the edge. So I want you to look at this photo first. This is a crowd. I'm going to go ahead and assume it was at some concert. And you can kind of, just as a human, you can look at this and see that there's a lot of people. They seem pretty happy. You can kind of get an idea of the age and sex breakdown, right? Male and female, and how old they are. And you can see this photo, which is quite an extreme opposite. People are pretty bored. They're not having a great time. And you can also get an idea of sex and age breakdown here. And so if you wanted to see how these people were feeling, you might give them a little survey, rate your experience, blah, blah, blah. But there's a lot of problems with this. A lot of people don't want to take that survey. And the few people who do take that survey, you don't really know what they mean when they say they're happy. Some people might only take it if they're really, really happy or really, really upset. And that might give you extreme data when in reality, the middle part was more normal and they just didn't respond because they didn't feel compelled to, right? So this kind of scenario pops up in a lot of different places. So if you're at a store, Black Friday is coming up soon, Cyber Monday is coming up soon. If you're at a store and you see a sales sign like this, says 50% off, you might look at it and walk out of the store. You might look at it for 5 minutes. The store has no idea. The store only knows that you came in and you bought something. And if you didn't buy anything, they may not even know that you came in. So this is a pretty big problem, that there's a big information gap in the sales pipeline. They don't know all the people that are coming, how long they stay, what kind of people come, and you don't know if men tend to leave or how old they are. So all the information is missing. Whereas online, it's a completely different experience. So on Cyber Monday, when you're looking at a deal, you might click on a deal, you might go on the page for 5 minutes, and you probably have an Amazon account, so they have your demographic information, your sex and your age. And they can see, well, which kind of deals are working with different groups, how can you increase retention, how can you increase conversion, et cetera. You have all this rich data from the beginning to the end of the pipeline, right, or sales funnel, and you don't have that offline. And it doesn't just happen in sales, it happens in presentations, including the one I'm giving right now. If it's offline, you probably don't have any idea of what I said about demographics and engagement. You don't know if the audience is bored or not, but online you have likes, dislikes, you have comments, you have views, you can share. There's just so much more stuff. So anyways, I'm sure you're all familiar with this. But how do we get that online rich data, output and insight in the physical world? Well, our company built this little magical box that does that. And so the purpose of this whole talk is going to be how our mindset was about going about building something like this and why we chose to build it. And of course, this being a Python meetup, pretty much all the software that was written that's on the device, I played a big role in it, and it's pretty much all in Python. So we had a client, it was around January or February, and this particular client was the Treasury of the United Kingdom. We worked with other companies like Accenture and so on and so forth. And they were going to have an event that spanned a couple of days, and they're going to have a bunch of different sessions, and there are going to be different talks, different speakers presenting. And this company, the organizer, they wanted to figure out how many people are going to show up to each of these little seminars, how long are they going to stay, how are they going to feel, what's the breakdown, etc. And since this is in person, they had no idea or no way of tracking that. And so they and we looked at existing technology. The first obvious one is RFID. So here, you get a little tag. Only like 10% of the people who get the tag's actually a dud, right? So only 90% of people have a working tag that's assigned to them properly. And you can use that to count attendance. So you might have to have them tag in or badge in every time they go in. There's also where you can just spend a bunch of money, like thousands and thousands of dollars on these these little big units, and then you mount them on the floor, and then they can scan people as they're walking around. But if there's like two people next to each other, it might miss them. It's like super duper expensive, like tens of thousands of dollars for a good installation with all the software and everything. So it's really expensive. It doesn't really work, and you can't get demographic. You can't get sentiment from that. So the other one's Bluetooth, beacon specifically. And for this one, you're going to have people download an app, so they have to kind of opt in. And then you have, it's also really expensive, and you have a lot of the same problems as RFID here. And again, you're still not really getting sentiment or engagement.
Rakshak,
yeah.
Someone is asking about quantum dots.
One second, I can't see that.
Did they ask about, is it the quantum dot?
Yes, it is. Yeah, Edge AI, yeah. So I don't know what quantum dots are specifically, but we're talking about an edge device that we built. I'm not familiar with quantum dots specifically though. This is just like a Bluetooth beacon on the bottom right, and the top one is the RFID. So if we look at this photo here, it's just a photo of an audience, and we can kind of get an idea. So in the visual domain, we have all this information. We can count the faces. We can see how happy people are and all that as humans. And so we think that computers should be able to do it too, and they can. You just need a camera, a regular 2D camera, nothing crazy. And this is a really simple example. And yes, this is with masks. So it'll do all the stuff I mentioned, even when you're wearing a mask. And you get all of this for free, right? Like you don't need to, not for free, but you get all this really cheap because you can just put one camera. You can cover our square feet, which is about like a third to 40% of a football field. And it'll analyze everyone. And it's all anonymous because we're not keeping the photos. We're not associating with identity. We're just reporting back, how many people came by and what kind of demographics they belong to and how they felt. And there's no like privacy constraints here like there are with the other technologies. And so you don't need to have people specifically opting in. You can just put it and you can capture everyone and cast a really wide net and see how your audience is actually feeling, and not just the ones who self-select to respond on a survey. This begets the question, what about computation? So we are talking about edge devices, but let's talk about the difference between edge and cloud really quick. So if you use cloud computing, like one of the famous ones like AWS or Azure, you need to get that data to the cloud, then you need to process it in the cloud, and then you need to pull back the results. Getting that data is really hard because each of these cameras that, if you were recording the footage, you can get easily over 100 gigabytes of footage a day per camera, right? Not to mention you're going to have many, many cameras being deployed. So getting that data to the cloud is going to be difficult. And then once it's in the cloud, the instances, like the GPU instances, are not cheap, right? So the actual cost of processing is going to be high. You have the edge. I guess on a very low level, you can think of like a Raspberry Pi as an edge device too. But there's also more advanced ones like the NVIDIA ones, the Jetsons. Intel has like the NCS, the Neural Compute Stick. Google has Coral, etc. These devices will process all the data on the device, so you're not having to stream hundreds of gigabytes of data or anything like that. Everything's done on the device, and then you can just upload a payload that's really, really small, so a few megabytes a day. So we're looking at a reduction of like 64,000 times for data transfer, and we're looking at a cost savings of thousands of dollars per camera per month, assuming the camera is being used pretty regularly. So there's a big cost and logistics difference here. But the edge isn't completely on its own. Like you can't just go and just do it. You have to build out the full thing. And our customer, our customer had a lot of strict requirements. They wanted to cover these really big halls, and so we needed really high resolution footage. So we could just put a single camera in a giant auditorium. So think of like a movie theater auditorium, or like in a college building with those big auditoriums. We wanted to cover the entire thing with just one sensor, right? So the footage has to be really high, like 4K resolution. We're going to be looking at it running like 12 plus hours a day straight without interruption. We're looking at over a dozen cameras a day for this particular client, and we need everything to work in a few weeks. And at the time, we only had the software working on laptops and desktops, like all the neural networks and the extraction process. We didn't have anything else. We didn't have it working on the edge quite yet. And so we decided, hey, instead of building the edge device and crossing our fingers and hoping that it works out in a sprint or two, it might be better to focus on what we can deliver, which is extracting the insights from the data, and just try to get a stopgap out there to capture footage. And let's just try to see if the customer really cares about having these types of insights, right? Like we don't want to go and build this whole thing if customers don't want it. We only want to build it if they care about it. And the best way to figure out if they care about it is to demonstrate it and do some type of trial with them, give them the results and see how they feel. And so we decided to use dash cameras because they're meant to be put in cars, so they can be left on for hours and hours and hours and not go bad. They can work under extreme temperature conditions, really bad. They can work with really bad lighting. If it's really dark and some of their high beams is coming at you, it'll still work. If it's really bright and the sun's right on you, it'll still work. It's just really great imaging for the cost. And we just said, hey, we just told the customer, you're not going to get the results live. We'll just give it to you later. So this is how we went, because we just wanted to go fast, right? This is really important. We just want to go fast and get something out there. And so the way it works is, this is one of the rooms that we actually deployed in. So we shipped them a bunch of these cameras. We put one camera. So remember, one camera is capturing this entire room, this entire auditorium. And then there's like 11 plus more of these throughout the venue. We shipped them the cameras. They installed it. They ran the cameras the whole session, so about 12 hours for all the different sessions that occurred. And then they shipped the SD card, the data from the SD cards on the camera to AWS. So we actually had the AWS is something called Snowball. So all the data was put on the Snowball, shipped back to AWS. AWS uploaded it into their London region, and then we put our algorithms and our code on a compute instance, and we computed on the data. We ran the analysis, and then we produced reports. And in the first case, we just sent them PDFs with figures, right? So no dashboard. And this is like just a little taste of what they saw. So for one of these sessions, which lasted about an hour, females tended to be more engaged for the session than men. And it looks like people that were millennials tended to be more engaged than Gen X. So females were actually 1.5 times more engaged than Gen X for this session. And we gave them a bunch of different breakdowns, and I'll show you some more examples later. But they weren't expecting this. They were really shocked. They really loved all of the different results we gave them, so they could actually justify some of the speakers they're bringing and how much time they're giving them and all that. And so we were like, okay, cool. We demonstrated the value. Now it's time to build the edge device so we can give them the live updates and we don't have to transfer all this data. Because getting that onto Snowball was a real pain in the butt. It takes a few days to ship it there, and they actually lost the device the first time, and so we had to do the process again. And in total, I think it took like 3 or 4 weeks. And the AWS team was like apologizing to us the entire time, but that only justified us having to build the edge device even further, right? So
before you go on, someone else is asking about I think Matthew Fitzpatrick, he's asking, are you recording data? You said you're recording the data is anonymous. Is there and not an issue? What about two-party consent states? I have no idea what it is.
What about what?
Two-party consent states.
Oh, okay. So there's 2 parts to this. So the first part is that when we did the dash cameras, in this case, we are keeping, there is actual footage. The client, because it was a part of the UK government, they required that all the footage remain in the UK, which is why it was, done through Snowball and it stayed in the London data center. And then all the footage after that was deleted. But the actual cameras, the edge units that I'm about to start talking about, those don't ever store any footage. And because they don't store any footage, they don't transmit any faces or any footage of anything. There's no real privacy concerns because there's nothing that we're producing that can be used to back reference an individual. So this actually is outside of the periphery of privacy concerns.
Yeah. And someone else is asking what the AWS service are you using? I assume Snowball?
For the dash camera pilot earlier this year, yes, we used Snowball, and it was a pain in the butt to get it to work. We did eventually get it to work. But again, that was just for the pilot. That was just to demonstrate the value because we wanted to bypass the edge device engineering for a few months just to see if we can prove the business concept up first. But we don't use Snowball anymore.
Okay, go ahead. I don't see any more questions. So.
Okay, cool. Yeah. So now let's talk about actually building the edge device, which is what y'all are here for. So the customer had 2 requirements. The first one was they wanted a live dashboard, which is one of the reasons why we're building an edge device. So as it's processing live, it can keep pushing out incremental updates on how the event's going, and then that can be shown on a dashboard on the user's laptop. The second requirement is that it's plug and play. So what that means is no fancy interface, no fancy setup, no sign up and download this app here crap. I remember one time I got a electronic toothbrush and they wanted me to use an app. I'm not gonna use an app with a toothbrush. I put it back in the box. Same thing here. No app, nothing fancy, no user account creation, none of that crap. Just take it out of the box, plug in the power, stick it on the wall, and it works. That's the goal, okay? And we want to be as close to that as possible. So we're throwing out a lot of kind of assumptions that people have when they're going about building devices. So we also have some constraints that we have to be considerate of. The user has constraints, the environment, basically environment, not the development environment, but like actually the physical place that the cameras are going to be mounted in, and the iterability. So how fast can we update things? Because it's hardware, right? We can't just always fix things with a software release like if it was a website. There's actually a big hardware component to this. So we want to make sure we can iterate. So to dig down into each of these one at a time, for the user, they have 3 big things: budget. They don't want it to cost a lot of money. They have very little time, and they're very stressed out. People who work in the event space, especially event planners, it's one of the most stressful jobs. It's like in the top 5, I think, or top 10 in America. It's one of the most stressful jobs that you can have because everything needs to work at once. And if any one thing fails, it can cause the whole thing to fall apart. And so it's a really stressful job, and we want to make their lives easier. We want to give them more insight into how they're doing things. We don't want to give them more chores to do, right? And so just really like plug and play, really easy, get it out of the way. They shouldn't worry about it too much. In terms of the environment or the field, the network is really bad in these venues. Starbucks Wi-Fi is like a miracle in comparison. We've heard people paying $10,000 for a week of 5 megabit per second data. I'm not joking, like crazy amounts of money. to get something reliable in terms of network. The base network that everyone's using, the public Wi-Fi, it's garbage. I don't need to explain that. I'm sure y'all have dealt with it. Variable lighting, so some places might be dark, some places might be bright. There might be like a big window because it looks pretty in the dining area. The sun is shining through. These can be problems with computer vision. Access to power, so there may not be a power outlet. There may be. We actually don't know before the event sometimes. No fixed mounting post, so you can't assume that you can install it on the ceiling. You can't assume that you can use a tripod, someone might knock it over. It's really hard to mount things. So this is like a really difficult environment to work in. It is not a clean server environment. This is quite the opposite. And then iterability, so we need to be careful on our hardware choice. We want hardware to be extensible, kind of general, generic, can do things in the future that we're not anticipating right now. We want a way to update the software easily on the device as needed. So I just re-enumerated those 3 constraints as nice, pretty, colorful boxes. So what we did was, for the hardware, we decided to use a USB camera, not too different from the webcam I'm using to give this talk. It's just we use a high resolution web camera, but it's just a USB web camera that you can buy on Amazon, eBay, Best Buy, etc. It's not anything crazy. And the reason why is that USB cameras are easy to swap out in the field. The other option would be an IP camera, but then you need to worry about the powering of that. That's kind of obtrusive. The other option would be a CSI camera. So if you buy a webcam or you buy a dash cam, you rip it open, there's like a little flat cable. It's called a flex cable. CSI cameras look like that. The problem with that is it's hard to change it in the field. Having the user change that is very difficult to ask for. For the base operating system of the device, we want it to be on a micro SD card. You can get devices that have eMMC, but if something were to go wrong, because this is an early nascent product and these are like really early pilots, we want to be able to have the user completely have a fresh, almost like a fresh device without having to reflash it. And so the cool thing about SD cards is you can just swap it out. So you have a backup or a spare. We chose the NVIDIA Jetson Xavier NX for the main compute because it has a GPU. It can run full desktop OSs if needed. And it has a general purpose GPU. So there's also like the Coral from Google, and then there's the Intel's NCS, which is based on the NVIDIA chip. The problem with, at least I have a better understanding of NCS, at least with the NCS, the problem with that is that if you have a neural network that you train, you have to do a conversion, a graph conversion, and sometimes it'll fail because they have you have an unsupported layer in your network or something. So basically, Jetson, if it runs on your laptop or desktop, it's probably going to run on the Jetson, but that's not always true for some of the other ones. And NVIDIA has a really nice, mature ecosystem, and I really like working with their stuff. So that's why we chose that. For the software updates, because the network's unreliable and we don't want to make things hard for the user, we're doing it as a file. And I'll explain more later down, but the main thing you should focus on right now is a flash drive. So with every camera, we ship a flash drive. It's just a regular flash drive, and you can download the software as a single file. You can configure the Wi-Fi. There's like a text file in the flash drive, and you just, first line is the SSID, the network name. Second line is a password. That's all you do. Get the flash drive, plug it in your laptop, change 2 lines of text, eject it, and plug it back in the camera. That's how you configure the Wi-Fi. No weird screen or weird setup process. You have to sync with your app or on your phone or anything. None of that. You might be asking, oh, but then your password's in plain text. Yes, that's normal because these are public Wi-Fi, or this is like the Wi-Fi password that's printed on everyone's badge kind of a thing. Like, this is not secret information. And then the network can be bad, right? And what if it never got to upload the data at all? It's only uploading about 4 megabytes a day, and it's like a trickle over time. It's not at once. But for some reason, if you just didn't have network, there's going to be a file that's a few megabytes big on the flash drive, and you could just give that to us, and we can upload it to the cloud manually. So that way, if something goes wrong, we can use that. For the software, we want to be able to change the runtime environment, including any libraries that we change, etc., plus the code that we change. So the way it works is we build a project out, then we create a Docker image as a file, we encrypt it, and then we upload it somewhere like Google Drive, and then we just send a link to our client. They click the link, they download a file. It's like about 1 gigabyte, not too bad. And they put it on the flash drive and they stick it in the camera. The camera recognizes that it's a new update. It automatically loads it in, and then it cycles out the old software. So this is great because you're not relying on the venue network to establish the update, and you're not duplicating the update across the cameras. Usually the event organizer or the client will have a better internet connection, but it's usually only like for their laptop or something. And so they can download like 1 gigabyte pretty easily. And then they can download it once, put that on all the devices, and then they're all updated. So this makes us do a lot of things out on the field pretty easily. The user complexity is super minimal. I mean, if you can use a flash drive and plug something into the wall and use a sticky pad, that's all it takes to install a camera, nothing else. You don't even need to know how to use a smartphone. So this is the device on the left is what we're shipping out right now. So we've shipped out a handful of these all over the world, in Turkey, in New York, in Belgium, and the most recent one went to London. So it's the edge unit is inside this enclosure, and this bottom little device is a sensor, and this is a flash drive, and then this is just stuck on with like command strips. So you just get it, it's like a little sticky peel thing. You put it on, you stick it, and then when you're done, you just pull it down and it comes off. It's very sturdy while it's there, and it's really easy to remove. So thank you 3M for that. So that makes it like really easy plug and play. And this is the device as we settle out some of the hardware components that we're experimenting with in the field. Any questions on the hardware?
So far, people seem to be happy. So I think you go on. There's someone who talks about privacy. Daryl, he's mentioning that people in California have some issues about being recorded. The new California
Right,
law.
but we're not recording, right? So we're not recording anyone. We have a legal team that keeps us up to date on all privacy regulations, and to the best of our knowledge, we don't violate any privacy regulations anywhere in the world, including California.
Nice.
Because we're not recording anything, and we're not retaining or transmitting anything that's identifiable. So this is what the client sees on the dashboard side. This is what they actually care about. This is from a real deployment. So this is not the Treasury one that I was talking about earlier. This is a different deployment we did in January. It was in Canada, I think in Alberta. So we have 3 slides, so I'll go over them one at a time. So if you look at this top purple, the solid one, this big blob right here, this is a presenter who's giving a talk from this time to this time, but there's actually 3 of them, okay? That's why there's like 3 humps here. So the first one is when he gave the talk the first time. This one's when he gave the second time. This is the third time. It's the same talk. He's just giving it back to back to a different audience each time. So we can see that we had at most 38 people at any given time. We typically had 26 people throughout these 3 sessions. Then we have the demographic breakdown by sex here, mostly female, and by age, mostly millennial and Gen X. And if you notice, this bottom lane, this is a sentiment. And so people right here, they're happy. And then they're not very happy. They're pretty neutral or unamused, I should say. And they're also even less happy or so here. So the first session, they're happy. The second session, again, same speaker, same talk, different audience, right? Second session, they're not very happy. Third session, they're really not happy. And so we presented that to them, and they're like, "Oh, okay. Well, maybe the audience changed, and the audience has a different composition in each of these ones." And we were like, no, we think that the speaker got really bored or they got really tired and they just didn't put as much energy in the second one. Because you have like way more people in the second one. This is a face count, this is a sentiment, but the people aren't as happy. And they're like, no, they came back. They're like, no, it has to be the demographic is different. Well, it turns out they're not, and we can tell them that. Because if you look at the sex, the proportion from female, which is blue, and male, which is gold, is similar between these 3 sessions. Right? Same with age. It's similar. Like orange is higher than pink in all 3 of these. And so it wasn't the demographics, it wasn't the audience composition that changed it. And this is sentiment. So sentiment between the groups, stays pretty similar between the 3 sessions. Same with face count. And so they were like really blown away by this because they're like, okay, well, we need to make sure our speakers, maybe they have enough time between the sessions to recharge or something. And so this was really meaningful to them. This is just one example. This was like one of the sessions we did out of dozens for this one deployment, and then we did a few deployments in January, February. Does anyone have any questions on the graphs? Cool. All right. So the last thing I wanted to mention was.
Wait. What does normalized happiness mean? The questions appear a few seconds after you ask.
Okay, that's a good question. So we normalize everything to where the scores for that session, they have a mean of 0.5. And the reason why we do that is if you have, let's say you have 2 sessions, you want to make sure that overall session, people were very happy or unhappy. You don't want it to be, you don't want everything to be based on the same absolute, scale. Like you wouldn't want to just plot the raw sentiment values because, everyone in this session might be really, really sad to begin with. And so the fact that you made them a little bit happier is meaningful, right? Because you're not responsible as a speaker for how they came in initially. Right, so we normalize every session to have to have a mean of 0. So all of these scores here, it should average out not 0, 0.5. Sorry, all these scores here should average out to 0.5. All right, and then we just plot the individual ones according to that relative baseline.
There's more question. Sherry is asking you try to give the speaker a break and see what happens.
Yeah, so that's something that the client can try next time is something to re-energize that speaker. Because when we told them this, before we showed them these two, right, the proof in the pudding, when we showed them just this overview, they were like, no, it can't be that the speaker is tired. We only hire the best speakers. They were giving their marketing crap, right? And when we told them like, hey, the data doesn't show that. It shows that something else is wrong. Like the speaker is probably tired, or it might be the time of day. It could be something like that. But they were able to go back and say, oh, okay, well, yeah, something's wrong. Like we need to go back and make sure the speaker has time to recharge. So
Shakita is asking, I hope I'm pronouncing the name right. What does the algorithm, how do you determine basically the age? What algorithms do you use to determine the age? What's the trick?
Wait, so your voice broke up. How do you determine what?
The age.
Oh, the age. Yeah, so we have like 2 neural networks on the camera. So the first neural network does the detection. So I'm actually going to go back to the one. This one. Okay. So if you look at this, we have this box. These are the bounding boxes. So we have one neural network that produces the bounding box locations. So it'll create one box for every face, and you can count the number of boxes to see how many, the face count or the head count. And then the output of that first stage is the thumbnail. Right? So we crop, like this is me on the left. So we just crop out my face, and then we crop out my co-founder's face, and then we run that to the second neural network. And the second neural network will predict the age, the sentiment, and the sex. And the way we accomplish that is by, well, this is probably not a very satisfying answer, but because I can't be too specific, but we have a lot of data that's been labeled, and so when we train the neural network, it just tries to generalize across the data, and then when it sees novel photos in the future, it tries to do a best guess as to what it thinks the age is. So the way the age works here is that we have like 3 age groups. We have like 19 and under, 20 to 39, 40 to 59, and then 60 plus.
Okay, there are more questions rolling in. So Sherry's asking if the second presenter was after lunch.
Mm-hmm. Let me see what the timestamp was. I think the time might have been. Well, this is 2 o'clock, and this is 3, so this is about 2:40 right here. I think they probably already had lunch well before any of these. They might have had dinner, around here, and maybe that's why these guys were happy when they were leaving. but I don't think someone knows lunch.
Okay, Florian is asking specifically if you ran into problems in the Jetson, like memory problems.
Oh, memory problems. So yeah, that's a good question. So we can use, we can use different variations of our neural network. Some of them are more powerful than others, and they require more memory. And so what we learned was that you can free up memory by reducing your constraints. So on the Xavier NX, you have 8 GB of RAM, and that's actually shared. For better or for worse, that's shared between the GPU and the CPU. And so we still have a little bit of memory to spare even when we're running at 4K footage. But in the future, so right now we can cover 15,000 square feet, about 100 feet directly from the camera in front of you, right? So it can capture quite a lot. But if we wanted to do even more, and we needed more memory, we would have to upgrade to, I think it's called the Jetson AGX Xavier, or Xavier AGX. And that one has 32 gigs of RAM. So it's like 4x. So we can upgrade the hardware if we needed more RAM. But for now, we're actually pretty good. We can run 4K footage. We can get up to people 100 feet away. We can do all these extractions, and we still have some room left. We're thinking about doing like mask detection, so we can see if someone's wearing a mask or something. We still have room for all that kind of stuff too.
So someone actually asked, how do you do sentiment with the masks on?
That's a good question. So what we did was we have our data set initially. We didn't have masks, right? It was before COVID. And then we got another data set in the last few weeks that had masks on. And we had to produce, we had to get the labels ready and all that for that. And what we did was we retrained the network for a mixture, right? So it was trained with masks and without masks. So it doesn't care. And our accuracy is almost the same now. It's like within 0.5 percentage points of what it used to be. So yeah, it's really great. Like you can still see the fluctuations. Like even if I put my mask on, you can still see that the happiness score changes if I'm smiling or not. We did notice that there's a problem that kind of like the baseline happiness level and the max happiness level will kind of vary depending on if you're wearing a mask or not. But that's not really an issue because again, we're normalizing these scores. So as long as in a session, either no one's wearing a mask or mostly everyone's wearing a mask, it should be fine. We really imagine too many scenarios where like half of the population is wearing a mask and the other half is not, because usually they're enforcing it or they're not. So yeah.
So Suman is asking, is the dashboard a Flask application with a React front end, or React /Vue?
So the dashboard, we're doing it with using a bouquet server. Like all the mathematical computation is being done in a Python, like it's on an instance in the cloud, and then we're shipping out those results, but the actual rendering is being done in I think bouquet.js. I personally didn't work on the dashboard. I did most of the work on the camera itself, so everything up until shipping out that payload. But yeah, I know that bouquet was used for that dashboard.
Ah, that's nice. So if you're using bokeh, you might want to come in next week to see the demo about HVplot.
Okay. Yeah, I can look at that, but I just want to warn y'all that we're about to move away from bouquet. So.
Yes, I know. This is what I'm saying. HVplot is probably something else that you can use.
Oh, okay, got it. Yeah.
Come next week. James Bednar is actually also in Austin. He's going to talk about it at the evening of Python coding next Tuesday.
Cool. Yeah.
Okay, so there are more questions. I'm not sure I'm keeping up with all of those, and
I mean, I think we're good on time. Just keep throwing them at me.
Okay. What if they're wearing sunglasses? This is someone who's trying to fool.
Oh, it doesn't matter. It really doesn't matter. Sunglasses, hats, we've tested on all of that. Even regular glasses, beards, facial hair, nose piercings, it doesn't matter. It works. It just works.
How do you update the neural network on your edge device?
Good question. So I'll usually train the network on one of my machines that I have physically. I'll do my tests on there that I wrote. Once I and the team feel like the network is actually better than the previous one, and we run all tests and everything checks out, we just create a new Docker image. So we run a Docker build command. So I actually have another Jetson that's sitting at my desk, and we use that as a build server basically. So that I have all my code there. The neural network is, the new neural network is just a file that's on that my dev machine. I just sync it to my other Jetson for development, and then I run a command that I wrote to build the Docker image. It creates the image. It packages everything, including the new neural network file. It writes it out as a single file. It encrypts it, and then we upload it to Google Drive. We send the link to the Google Drive file to our client. They download a single file, copy it to the flash drive, plug it into the camera, and then it's updated. So neural network updates are no different than any other software updates.
Jenny is asking, it's a long question, I'll summarize it. Basically, it's asking, how do you make sure that the speaker is speaking the same thing between talks? Just like, does he memorize the same things as the speaker?
Not sure. I'm not quite sure if I understand the question. Can you say that again?
So you had the speaker speak free. Here, I'll just read it.
Oh yeah. There's three sets. Yeah. There's three. Yeah.
It's scrolled away. Sorry, Jenny. There's so much I can do through, but I'll try to explain. You have 3 sessions of the same speaker. How do you know the speaker is doing the same thing? Does the speaker memorize it from the user experience?
Yeah, so that's really on the client, right? Because the client already has a scheduling of who it doesn't have to be for a speaker. It could be for a restaurant. It could be for anything. But the client already has an understanding of when certain things occur, right? So if there's a speaker, usually the speaker will have a start and end time. So they just have to back reference to that because everything has a timestamp. And then if your question is like, how do they know which camera it was? When the user sets up the camera, there's another file, like how there's a Wi-Fi configuration file. There's another file called camera name, very creative name. You open that text file and there's a single string and you can call it whatever you want. So in this case, it was like up on the top left, you can see what it was called. And so when they set up the camera, they'll usually name it after the room or the session. And then that's how they know which sessions that data comes from. And then the timestamps is just from their own schedule that they created.
Is there a way to measure things?
Measure like what?
I don't know. That's the question. Can you measure on the image or something like you measure how people are sensitive? I don't know, distance between people. Yes,
that's a great question. So everything I showed you today is stuff that's already working, that we already have out in production, that's being used by clients. In the near future, we're planning on releasing social distancing detection. So we can. So it's really cool. We can have the camera. It's like this. It scans out. The camera sees things in like X, Y plane of view, if you will, and then we wrote some code that can translate it to X and Z, or whatever the third dimension you call it is, or X and Z to X and Y, right? And then we can map out using projective geometry where they are in the venue, so that you create a heat map, and then you can see between points, a point being a person, what the distance is between those points. And so we did this, I actually built it in, I want to say February before COVID hit. So I did it before social distancing was even a thing. And we were getting, at like 30 to 50 feet away from the camera, we were getting like 5 inches of error.
5 inches of what?
Of error.
Error, error, okay, got it.
So like 30, 50 feet away from the camera, the error between the points was like about 5 inches. So it's actually pretty good. If you're looking at like 6 feet or 2 meters, 5 inches is not going to make a difference.
Okay. If someone wants to ask a question instead of rolling them, because I'm trying to keep up with all those questions. But if someone wants to actually ask the question, if I missed it or something, unmute your mic and ask it. It's okay. I'm trying to do it for you, but some people talk about how you train it. Do you have like a specific training set, this custom one, or do you train your own?
Yeah, so for this presentation, I can be pretty open about the hardware. The software we're a little bit more secretive about, but I can say that it's in PyTorch. We collect our data, and I've been doing machine learning for like 6 years now, and my CEO has a PhD in machine learning too. That's probably not a good answer, but
so So
I mean, we
so why did you select PyTorch and not some of the other competitors like MXNet or TensorFlow or whatever?
Yeah, so TensorFlow, so TensorFlow, I believe, came out in November 2015, right? It's like 5 years ago. I used TensorFlow before it was, 1.0, and I used it up until 1.12, I think. But I kind of just got a bad taste in my mouth with TensorFlow. So it was just a personal decision. I moved to PyTorch when it was still 1 point something, and I just never looked back. So.
Christopher, you want to ask a question?
Yeah, I wanted to ask about doing things like measurements. Like, let's say I wanted to measure somebody's face or measure, how, like, measure somebody's hairline or something like that. Is it possible to do something like that?
So what would your output be? Would it be like the number of inches that the hairline is long, or like what are you?
Well, let's say, for example, I was, looking for, people who were over or under a certain threshold.
Oh, okay.
Let's say, for example, I was, not applying it to people, but say, I wanted to look for squirrels that only had tails over 3 inches long or something like that.
Yeah. Yeah, I mean, you could do that. So you would need to build a squirrel detector or find one, right? So there's different detectors you can find, and you can train it on your own data.
Yeah.
And then you would need to, you could either measure the squirrel, you can measure the tail. I would measure the whole squirrel so you have some kind of a baseline or reference, right? And then, so the thing I mentioned earlier about social distancing, that you have to calibrate it. So you would have to find some kind of projective geometry approach, and then you have to calibrate it for your camera. So you need to figure out. But what the projective geometry does is it lets you lose a dimension, right? So remember I said on a floor plan you have like X and you have Y, where initially you had like X and Z from the camera. So you kind of lose. You still stay in the 2D dimension, but you can still see the distances between points. So I would just look into both of those. So try to train or find a detector for that, and then you can use projector to actually get inch measurements.
Well, you might not necessarily need something that detects squirrels. I mean, somebody who was just looking at squirrels. I mean, but wanted to have something, that would measure. I'd say, okay.
Oh, yeah. Well, the thing is, you need to have really good information on your camera's orientation and position for that.
Okay. Yeah.
Which you might be able to get from the metadata. I haven't really looked at image metadata too much. You might be able to get that because I know smartphones can capture that. I just wonder if they code it in the metadata. But if you can get the orientation of the phone that took the photo, you might be able to do that. But you need to have the same unit, like you need to have the same kind of phone so you can do the calibration.
Okay, I see. I think we got most of the question. Yeah. Yeah. I suggest at this point, if I missed someone, I apologize.
Sure. I had one more thing at the very, very end once everyone's done. So I can go to that if there's no more questions.
Let's skip to the end. We'll have more questions at the end. If there are more questions, then people
Sure.
will ask after both presentations.
All right. So this is the final part. My company is currently raising money publicly, so anyone can invest. You can scan the QR code or that URL; they're the same thing. So we've been doing pretty well. We launched over a month ago. This is our status so far. That's how much we've raised and all that. And we have like a lot of information on like more of the business side of things. I didn't want to focus too much on the business side of things on the talk, just to kind of set the context. Yeah, we have all the information. We also talk more about how we respect privacy, the size of the market, and all. And we've done a lot of deployments all over the world. We've done hundreds in the world. So yeah, just take a look, check it out. That's me, so I'm not an imposter. I'm just like some random guy presenting on some other company. Yeah. Cool.
Okay. Thank you for presenting this. It's nice that you're doing well. Hopefully, you'll do extremely well. And if anyone, by the way, if you're hiring, you can say it. It's okay.
Right now we're not,
Okay.
but in the future I can mention it in the meetups.
Okay, good. So we know that hopefully you will succeed well in all of this. If anyone has any other questions about Python related or how we do, because Rakshak has showed some of the things, some of them are secretive. I understand why. I wouldn't tell, but you already revealed what are the tools that you're using, which is good. Um, by the way, as part of a discussion, TensorFlow 2.0 is much better than the versions you were talking about. It's really good. And we lost your you lost your voice.
Oh, sorry. Okay. Can you hear me now?
We have a lot of noise. I think we lost your voice now. Apologies. Yeah, it's something with your. Now he froze. Okay. Oh well. Now you're better. Now you're
Can you
back.
hear me now? Okay, yeah, I'm glad that didn't happen in the middle of the presentation, but
So TensorFlow 2.0 is much more stable. You might want to give it a try. However, I'm not sure how well it will deploy on those GPU cards. I'm curious to know.
it should be fine. I don't think there's any I think TensorFlow is probably better than PyTorch at deployability. But yeah, I just fell in love with PyTorch. I haven't looked back, but I don't mind using TensorFlow. If like someone wants to work with me in a project with TensorFlow, I'm cool with it. I've used it. I used it when it was ugly, so might as well use it when it's pretty, right? Like it's.
Yeah, they have several new features. Actually, you might want to. I think one of our guests today gave a talk related to TensorFlow a while ago on the Python meetup. If Evelyn is here, he can jump in and say something.
Yeah.
Any more questions to Rakshak?
Cool. And final plug. Check it out and invest.
Cool. Presentation. Appreciate it.
Yeah,
Which cloud provider do I think is better for video analysis? I don't know if I'm the right person to ask because it depends on what analysis you're doing. Are you using something that's pre-built? I mean, if you're using something that's pre-built, just go use the different ones, get a free trial, and use their APIs. The thing is, we're custom building everything, and we're not processing in the cloud. So I don't have like a lot of answers. But I mean, in the past, we used to do. We used to use AWS. Like we just use the CPU instances. We didn't even use the GPU instances in the past. You can get away with CPU instances too. It is a lot cheaper.
Rakshak, Evelyn, he's online apparently, but he's texting. He said he would like to see the presentation, and I see an interesting connection. You're both Austin-based companies. He's doing home survey. How do they call it? Home surveillance or home automation. You know, all of those things that plug into the home. And this is something you might want to connect and talk to him. And this is, usually I don't do this while we're recording, but this may be an interesting connection because he wants to look at your presentation, connect to him, or send me an email afterwards, I'll connect you to. He has a local company that you might want to, your product might connect to them.
Well, yeah, I'll text you right now. What was his name?
Evelyn.
I'm here, I'll follow up. I already got the link from...
Evelyn. Oh, hi, nice to meet you.
Great presentation, man. Good stuff.
Thank you.
But Evelyn, is it something that connects to what the things that you're doing? You can speak up.
Yeah, generally there is a bunch of stuff that's relevant to the custom models for image recognition and all kinds of analysis. But I'll follow up offline with Rakshak.
Yeah, but tell everyone what you were doing, because he presented on TensorFlow IO or at the beginning of TensorFlow IO. Actually, there was some other presentation later. But can you remind us what we're doing that connects?
Yeah, so we're running Ambianic, which is an open source project. It's focused on home care, remote home care, and a lot of use cases have to do with taking care of people that are locked in their homes and are trying to age on their own, not in a hospital, and being able to keep an eye out for fall detection and things like that.
Yeah, I was talking to someone this morning about that. He said that there's people using radio waves to get through walls, and you probably don't want to put a camera, no matter how secure, in a bathroom. So they were using radio waves.
That's right. This type of conversations are happening around the project.
Yeah, no, I love to connect. I'm always looking to meet people.
Okay, so it's both you're both in Austin. In COVID time, it doesn't matter a lot, but you might want to meet both of you and talk how you cooperate. Maybe you'll do some mega product, and maybe you'll talk about it in the future in another Python meetup. For now, I think we had enough of this talk, so I would like to thank you. I'll clap my hands. Everyone can make noise or whatever, or the chat.
Thank you.
Okay, you have thank yous. It's people clapping.
Thanks, guys. I appreciate it.
Okay, by the way, you had a nice attendance. We reached about over 50 people at some point. So
nice.
This is actually for COVID times. We had big Python meetups, so at COVID times you were doing very well.
Okay, awesome.
So now the question is, who did they came to see, you or Num, or both? So now we're gonna.
Well,
we're gonna make.
I came to see Nam. I came to see Nam.
Okay, Num. So okay, under those conditions, I think this is a nice segue. Rakshak, you can please mute yourself. Everyone else, please mute yourself. And Nam, you can take over the screen and tell us more about packaging that you do in Nom.
All right. Thanks for that, Rakshak. I at least know someone's going to stay till the end, hopefully.
I got you.
Just a quick show of hands. Can you guys see this?
You're good.
All right. And then how many Python developers here do we have that are kind of like more back end, don't really like build UIs, have a few stakeholders that they usually deliver stuff to? Okay, yeah, more of that. How many of those people that do the back end stuff think they're the first person to ever build the things that they're building? A few bit fewer. So the why this like kind of company came about was so many people building custom projects for deploying stuff, seeing their projects either succeed or die or fade away, and only being used by like a handful of people. And what I kind of found was when I went job searching, I noticed I was like, oh, hey, everybody's really kind of asking for a lot of the same things. And I was like, why can I not expose what I do easier? Like, why is that so difficult for me? And I was like, oh yeah, it hit me. I suck at building UIs. Like my UIs are crap. I did, a big Flask Vue.js project one time, and it was like, I had all the underlying functionality for what I was trying to do, but the only people that were using it were like my fellow data engineers at the time, and only the Python ones really that were using it. And I was like, well, trying to get like analysts to use command line stuff, and they weren't having any of it. And so I built, a really simple UI, and they kind of loved the ability to interact with UI, but it still kind of sucked. And then when I went around searching for jobs, everybody was asking for like, oh, can you build something similar to that? And so, for me, this is kind of about taking things that a lot of developers are doing and making it more usable by other people. And I would say open source doesn't really kind of do this 100%. I mean, other developers can use it, but I kind of wonder how many more people could use your stuff if you had UIs on top of it, if it was easier for people to, install and run without having to set up Python environments and deal with Python packaging and all that kind of stuff. And so, that's the reason for why we started down this path. And just a quick show of hands, has anybody ever kind of experienced that on like small projects or, code that they've built and they're like, man, I wish that could have been used by more people? Yeah, sometimes. Okay. So
You have a lot of yeses.
a lot of yeses. Okay, there you go. It's in the chat. I can only see like 6 or 7
I'm
faces
not
in
a
the screen. So
representative. Whatever I do, like 2 people in the world do the same. So
right. And so as a back-end engineer, I was like, okay, if I want to increase my value, I either got to go sell more time, build more code for somebody else, and this is kind of leading to, all my code belongs to some other companies, or my other option is, do it open source, give away for free. I feel like there's something in the middle, and the way to kind of increase value of your code is to increase adoption. So the ways to kind of do this for us, first was kind of make it easier and simpler for people to use your code. Because not all of them know Python. That once it becomes simpler and easier for them to leverage, that potentially increases adoption. And then once you kind of have adoption going up, one of the things that I think a lot of Python developers don't want to do, and when I talked with a lot of people from various companies, just deal with the minutia of, oh, I have a lot more people using my stuff. Now I have a lot more support requests. And so how do you kind of like manage and maintain that as you have like 5 people using your stuff versus 10 people versus 20 people versus potentially hundreds or thousands of people using your stuff? Because I think in many cases, more of what people are doing today, especially on the back end, applies to thousands of companies across the globe. And so from our perspective, we were like, okay, how are people kind of using things? And if we're trying to make it more business user friendly, apps kind of make a lot of sense, even though on the back end, I only use like 4 apps on my phone, but I feel like they're kind of like an easy thing for users to grok when dealing with like complicated components. And so what this means is like the user has to be able to configure, what they're running, and it has to have some sort of like parameters and things like that associated with it. You have to be able to like deploy it like a package, have it run in multiple places. I think everyone here that knows Python is kind of familiar with that concept. Has to be fairly self-contained. So what it does need to be self-contained in almost every case, especially in today's world, it's interacting with second or third-party services or systems. And then, the other thing is that we wanted it to be really, really easy to build. And so I think when people initially talk about apps, they kind of think about apps on your phone. And most people that you talk to kind of think building apps on your phone is a fairly significant time investment to go down that path. And most like good apps on phones are built by people or teams of people, 5, 10, 15 large. I mean, one of our big clients is a $1 billion gaming company, and they've got like 20, 30 developers per game that they produce. So the next thing that you kind of need is some sort of platform that these things run on, and whether it be like Google Cloud or Amazon. I felt like everything is kind of moving in this SaaS direction, and it was really important for us to kind of produce something that you could run on your laptop and run packages from other people and be able to find things. And what the platform kind of helps you manage is the UI of things, especially if you're a backend engineer and you suck at building UIs like I do. There's a lot of things that backend Python developers build that don't require very complicated UIs, but they still require configuration. And so this was kind of a starting point for us. It has to handle like the automation, triggering. If you're kind of selling apps for backend tooling for things that like companies do, then the goal of that is to automate. And I feel like if you're a developer, your goal is to automate things, make things simpler, And I think we're getting to a point where it doesn't have to be within a company. I think there's lots of companies where just doing that will make an amazing amount of value within the company. But I think for developers, there's the opportunity to take your knowledge and, instead of doing consulting as a side gig, sell an app as a side gig in terms of generating a revenue stream for yourself. Why does only Google, Amazon, and Microsoft build software that people pay subscriptions for, right? I think that individual developers have that capacity too. It's just that putting it on GitHub is not the way to do it because, unless it's been out there for 10 plus years and you've got millions of people using it, people don't really look at random open source projects in a lot of cases. And then the platform has to handle security. And, I would say mobile apps, it's a little bit different. And I'll kind of dive a little bit into the architecture about like what we're doing. I mean, it's really more of like a containerized Docker thing, but Francisco kind of had a comment around mobile apps. And I think a lot of 97% of mobile apps out there are kind of crap. This may happen. I think a lot of developers write code that or like functions that eventually drop off, but the culmination of all that is getting to apps and functionality that really is valuable across broad spectrums, and it gives people kind of the ability to iterate on apps and continue to work on them and publish them, and then kind of like potentially monetize or share them with lots more people and drive adoption. And so that's the end of that part about like why we are building what we're building. And so the rest is going to be Python code and UI type stuff. And so for us, I don't know how many Python engineers here are data engineers or have worked with Airflow. If you are, this is kind of familiar. I would say this UI, our goal is to make this thing free. Versus a PWA. What's a PWA? Greg, sorry. Progressive web app. I would say ours is more of a progressive web app. This is not
because people like in the recording missed it.
Oh. So Greg Ludo asked why native app versus PWA. Is it the revenue side of things? I'm really classifying it as apps just because it's definitely an overloaded kind of term. We initially called them engines because we were kind of like more data centric, but people didn't really understand what they were. And the notion is that you have a enterprise grade kind of UI automation platform that you can have users log into. You can subscribe to different functionality. You can schedule instances of them. You can have projects. And so one of the things that as a backend engineer, especially in data, that I found is there's just so many different types of apps and integrations that people are trying to do, whether it's pulling data from like internal apps, whether it's scraping data, whether it's syncing third-party systems, whether it's pulling data from APIs, whether it's generating APIs, whether it's triggering things to run. Like all of these things were things that across various jobs that I had to build, and just like maybe it went nowhere. Maybe the company's still using it, but potentially would have added a lot more value if the world could have used it. If everybody could kind of share and be like, oh, hey, Jacob wrote, this really great, amazing app. I can now run it, and I can just subscribe to it and just run it on, this free platform that enables me to automate and schedule and manage permissions and do all this other kind of stuff for free. So in our, if you want to talk about like monetization and revenue, we open source a lot of like the components and the SDKs around this. The platform itself is not, but I think, our goal is to help developers share and distribute code and the things that they build in an app-like fashion, and potentially monetize those things. And so the monetization of that is kind of like potentially contrary to some open source. I mean, I think some open source companies are open source so that you can build and they can like make more money on their side, I feel like there's an opportunity to have developers build and contribute to things and make money for themselves. And so this is what the UI initially looks like. And our backend SDK and everything is written in 100% Python. And so this is like a very simple app. We have the nom data SDK components. You basically define an engine, which, you know, I'm going to go ahead and change this, which is hello Python Meetup. I'm going to leave that the same, hello world. And what you do is you basically start with some function. I would say apps can do anything that Python can do. So we've started off with apps that do some like sort of cloud management, cost management. There's web scrapers, there's loading data into databases, there's pulling data out of databases, there's automating SQL statements, there's running bash scripts. And these are all things that various companies have. You know, some have like really, really good architectures for this stuff. Some have like, you know, cron scripts running on Windows boxes in closets. But I feel like there's opportunities to kind of streamline a lot of that stuff. It's just that the default right now is you got to hire somebody that's got to look through a bunch of code to architect something that best fits. And it's just a lot of work. So everybody just kind of keeps it the same. But sorry. And end result is like, Python can do a ton of amazing stuff. And if you can write a function that takes parameters, then our goal is that you can build an app. And so in this case, hello world takes in a name to say instead of hello world. And it's just printing out hello world to the log. So we say how many times. And so this parameter says, great, I need a string parameter here. I need an integer parameter for repeat here. And then I have this action. And the action and what this kind of translates to is to a task that we can create, which is actually, I'm going to change the name of this because I have a few demo hello worlds. So I'm going to demo deploying this. So here's my terminal, live deployments, python main.py dump YAML. So one of our goals with this is to create language agnostic apps. And so the architecture of the platform is such that because it's just Docker containers running underneath the hood, maybe there's something that's optimal to run in Python. You know, we're starting with Python because that's what we knew, but maybe there's some other stuff that's like optimal to build as a Java app or a .NET app because it's interacting with Java-centric things or Microsoft-centric tooling. We want people to be able to do that because in some cases it's easier to manage things in the appropriate languages. And so we basically templatize what the UI renders into JSON definitions that kind of get passed back and forth between like instances of the apps. And I don't know how many people are familiar with like Kubernetes or kind of like deployment systems, but yes, exactly. Very similar to Helm packages on Kubernetes for defining the services and, you know, credentials and connections of things that get started up. So then we have our command line, engine, tools, model, update, stable. So we kind of instituted channels, and so this allows you to kind of roll out apps to different tiers of deployments. So we have dev, beta, and stable right now. I think eventually it's going to get to the point where enterprise clients will be able to like pin themselves to specific versions of apps, and since they're just like different Docker containers on the back end, it's not really a problem for us to kind of house and manage all of that. And our ECR repo is AWS anyways. So I'm going to refresh this. I just updated the model template, and hopefully it will say hello Python Meetup instead of hello world sample. And we can kind of create a task that models that. Engines. Maybe I didn't save it. No, it still says hello world. All right, so save that.
So while it's running, let me ask a question. Maybe there are other questions. Basically, you provide environment in which to run an app, and how do people plug it in? Using your environment, or do they have to provide you like a Docker environment?
Yeah, so they have to provide a Docker environment. You have to install Docker for the package to work. And then once you have Docker installed, the platform itself is a series of 7 Docker containers that does a bunch of services ranging from logging to queuing. There's an API layer, there's a UI layer, there's a traffic networking layer. And so there's actually a single executable that you run and then install it locally. And that was kind of like an interesting thing for us as well, considering how data is so crucial. I think there was a lot of comments around like data security. There's a lot of data platforms out there that like, hey, yeah, pass your data through all of our SaaS systems, and we'll do whatever we want with it. And we felt like it was really important for a certain class of people to be able to own and manage their own stuff if this is kind of running inside of their own environments and the apps and the functionality are coming to them, then they kind of control what it's accessing and kind of what it's doing. But rather than the defaults of, hey, we need to do this thing, let's go hire Jacob, they can also have the ability to be like, well, let's check and see if somebody's built something that already does that. Or they can say, well, we can also build a custom app that's private to us, that's internal, running on this platform. And then we can have a whole bunch of like different apps and things kind of running together that are more plug and play. And so this becomes really important, especially in like enterprise or data systems where we've had clients jump ship from AWS to Google Cloud, and it's been like super painful for them because they had to rebuild a whole bunch of backend tooling to kind of facilitate a lot of that stuff. But if they had apps that just did those things and had shared configurations, they could just swap out apps one piece for piece. And I think it's kind of becoming more often nowadays for companies to switch services or try out new services and things like that. And so, we have a new engine type here. Hello, Python Meetup. I'm going to create a task for that. Live test Python create. And so this is the UI that got generated from those decorators that you guys saw. So we create this. It shows up. We can run it. We can schedule it. We can schedule things off of other people's schedules. I think in some worlds, one of the challenges I always faced was finance has one scheduler, front end teams have another scheduler, and you just got to like try to time things appropriately. If you have an ecosystem where everybody can deploy tooling and trigger things off of each other, it smooths out a lot of the guesswork of like when things are done, when can I run my stuff, when can I trigger my events. All of that stuff becomes easier, and then this kind of handles like logging, resource management, security, shared configurations, all that other kind of stuff. Any questions?
How does execution happen? Like if let's say I have 3 apps and they need to talk to each other, each one of them is kind of polling or waiting for things, or is it like one can trigger the other to run from scratch, and then when it's over, the third one will start? Let's say an event from the user logged in, you want to show him something, and they do something. And then when they're finished, the report is being generated by a different app, and the third app, let's say, archives it somewhere.
Yeah. And so in all of those cases, you're interacting with some third-party service. And what happens is you would create a sequence that maybe triggers or runs and manages all of those things. So I would potentially, run the demo hello world. It would produce some output, put on an S3 server somewhere, or load some data into a database. I'd run my second app, which may generate a graph. I could run it on a time schedule. I can trigger it off of another schedule that's running. Let me increase the browser font size. And so this is where like a lot of the automation that I think, I've built in various, not too big, various pet projects that ended up dying because I felt like a lot of developers are really good at building the functionality for the job that they're trying to do. Where I tended to fail in the past when I didn't have multiple years to work on a platform that could really handle enterprise concerns was those things would generally die once the company hit a certain size, because I was not able to build enterprise security into the things that I built. And so then eventually some product manager will be like, hey, we can either, use this project that Nom built on open source and, do all these things, or we can go spend, 6 figures on this enterprise level thing, and that enables all of our business users and analysts to interact and empowers them and does all these things. And part of the reason why we did this was because I feel like if the backend developers had a platform where they could kind of present their functionality that they built, their knowledge in a way that was enterprise grade, those conversations don't have to happen as much. And then, Python developers can give the gift of their code to a lot more people because their code is valuable. It's just the way that people are consuming it changes a lot.
So you're saying that there are 2 elements here. A, it allows you to integrate multiple platforms, but also it skips the need for developers to develop complex graphic user interfaces and security things. Am I correct now?
Right. So we kind of built out the security. There's a lot of things like projects, who has write permissions, who can access credentials. You can create a project where, say, maybe I have access to run jobs or configure jobs, but I don't have access to see any of the credentials that I'm interacting with. That may be one use case. And I just found that as a backend data engineer, I really enjoyed building things and driving the business value versus spending time working on permissions and UIs, which ended up taking a lot more of my time. And usually for backend teams, I've had several projects where we've requested a front-end UI person, and that's not the kind of project where companies are willing to give up a full-time front-end person for back-end projects. And it also feels like for back-end projects, front-end people are just kind of like less interested in it.
Interesting. More questions, please. I'm trying to figure out if we missed something. Yeah, there was the question about Helm. Okay, let's. Sherry is asking, would you have a better? Would you have done better with a full stack person?
So I would say that we started off full stack, and I would say that there's kind of this like, I don't know, I guess this like meme where it shows a front end. It's like a picture of a unicorn, and it's like done by a full stack engineer, and it's the stick figure drawing of a unicorn. Uh, I don't know if anybody's seen that meme, but it's kind of the joke that like real front end UI people like say when they're like, oh yeah, go hire full stack engineer. And obviously that varies from person to person, but I would say that there's a lot of back end engineers that, you know, even if they know how to do UI, it's not like as intuitive. It's not as scalable. I mean, when we were building this for us the first time, you know, that's what we did. And then when we got like a real UI person, it was just a world of difference, both in terms of maintainability of the code in the back end, and as well as the intuitiveness of how people would actually interact and use apps. And so, you know, I think once you start adding a lot more things in terms of inputs, you know, we have different kind of code blocks that people can put into the system, JSON blobs, like managing configs, like those things kind of needed someone that was kind of back end as well as UI, and so we just kind of had a UI person that we trained to be more back end for that kind of stuff. The other thing is that, you know, I think for especially in the data world, testing was also kind of an interesting challenge. And so, you know, we use PyTest, and our SDK kind of bakes in PyTest for the apps. And it actually made deploying and management of the code a lot easier. And so one of the things that I experienced, and one of the reasons why some of these like open source homegrown projects that I've done in the past ended up failing, is you can start with either a monolithic approach, and I think the rage now is microservices. But either way, I think on the microservices, the testing is a lot easier, but there's still this notion of like, okay, I have 45 different repos deployed. How does it interact? Oh crap, data engineer X left and something broke, and now I've got to sift through like a million CloudFront logs to kind of find this race condition on like why my data is not being processed. And so, you know, one of our thoughts is having a system that can like manage a very large scheduling mechanism and triggering mechanism across different languages is potentially really valuable. As a data engineer and a data architect, one of the challenges I always had was, hey, something's broke somewhere. I don't control that code base. Go talk to these guys. And so there was a whole bunch of like throwing things over the fence. And, you know, building things in an app-like fashion and then deploying apps and managing the packages in that way kind of gets to that microservice architecture. But I think it also, by leveraging a platform that can handle the security and the executions and the triggering, it's almost like a managed microservice architecture where things get tested kind of in the appropriate areas. And in the monolithic systems, I've seen tests that try to like walk through the entire gamut of what's going on, only to find that tests take, you know, 4 or 5x longer than it does to actually like write the functionality that I'm working on.
Any more questions? I see testing something. No, this is just Sherry. She usually documents some of the things being said.
Yeah, I have a question. Can you hear me?
Yeah.
Yeah. So, like, what would be an example of a app that people, let's say that you saw your clients or your users use the most, or like I'm trying to envision what an app, like what I don't know, like I'm trying to figure out like what an app would look like, what and not how it would look like, but like let's say I'm building an app, and then you have company A using it, company B using it. Do you have an example of those kind of apps that actually say developer built and then is being used by multiple companies, and then they found it found a lot of value into it?
Yeah. So one of the real easy ones is how many people here are familiar with SQL? Yeah.
Yeah.
Okay. So SQL is really powerful, and if you couple it with scripting or programming languages, it becomes pretty amazing. Yeah, SQL. And I think that there's a large swath of SQL users that want to be empowered to do more, but don't want to learn all the programming language type stuff. And so one of the most successful apps that we've built so far is just a generic thing that automates SQL with templating, with moving date ranges that the users can configure themselves to integrate with the things that they're doing. And so the first one was just automating SQL. So there's a SQL code block, they put it in, and they just run it. The other is, and then they said, well, great, I need to take this and deliver data from a database to person X, and it's on FTP. So that's one that's like really easy to see that there could be lots of use cases. And then it went into, hey, I want to send things to Slack. So there's a, MySQL to Slack app that someone configures SQL, they plug in their Slack app token, and then it just writes it to, the results to Slack for them. Same thing for email. Same thing for, we actually have a bokeh app where you just, it is a lot like Airflow operators. The difference is that Airflow is code only, right? So you're limiting yourself to who can use it. And so what this turned into is we have marketing analysts using this. We have customer support people using this. We have, BI people using this to own stuff. And so there's other apps that are, how do I load data into BigQuery, or how do I load data into Redshift or Snowflake? And so I think before you had to find a developer or data engineer that was good at all of those things if you wanted to really, build out warehouses in those systems. And now you're like, well, if I just have the apps to load the data, my analysts have a lot more power to do things. And I think this is kind of moving towards, as companies are using a lot more of the same systems. And even if they're not, these big companies are building these apps, and Amazon and Microsoft are kind of building apps as well. But there's so much long tail in terms of things that people are trying to automate on the back end. We hear stuff from companies like, hey, I want to automate or sync tickets from Jira into, XYZ customer support system. And the challenge with using the apps only of those systems, because Salesforce would love to lock you in forever, is that companies switch systems. So by having a system that you own and control and can plug and play the different things that you're using and only pay, a subscription fee for that stuff, versus I think a lot of SaaS companies are charging, per ticket transferred or whatever it is. There's this kind of middle ground, I think, that can exist where potentially a developer that's really good with a suite of integrations or a particular set of use cases, they can just build a bunch of apps around Shopify or HubSpot that do a lot of these things. And I think there's an opportunity for those people to create revenue streams for themselves as a side gig versus consulting, right? You're actually producing packaged products that someone could potentially use without you even having to install it for them.
So you already have the built-in monetization system for the developers. Let's say you build an app and then it's being used by multiple companies. Do you have something like that built already? Or?
Yeah, so we already are tied in and integrated with Stripe, and I think we're using ChargeBee to manage subscription, because Stripe wasn't really great at handling subscription type stuff. They
Okay.
did subscriptions, but you were limited to like 20 or something like that. And we're trying to scale this to potentially have, all these back-end developers that are just working for one company. What they're building is probably valuable and applicable across lots of companies, right? How
Yeah.
many companies are spinning up and managing AWS resources? How many companies are need to like collect the costs for AWS or shut
Yeah.
down random EC2 instances? These are functions that we've all built before, but I'm like, great, I got to go do this.
Yeah.
I'd rather
Yeah,
just find an
I
app.
can think right now like of a bunch of like we have, for example, we are shutting down our development um, uh, environment in the night, so you don't spend the money. That would be like a
Right.
perfect application for this. Yeah, I can
And
see. Yeah, I can imagine a lot of applications.
so
Yeah,
there's a lot of stuff that also turns into kind of Helm chart like stuff. And so we have the notion of shared configs, and these are kind of like user-defined JSON configs that can be shared across different kinds of things. And so the first use case for this was kind of like data definitions on a data lake. And so when you look at an S3 data lake, you say, great, I have a folder, it lives here, it's full of CSV files, here are the columns. And if you had that, you could plug that into an app that loads data into MySQL, an app that loads data into SQL Server, an app that loads data into Snowflake. And now, when someone says, hey, I heard about this thing, it's called Snowflake, do you want to try it? It's not going to be like, oh, this is a 4-month project now because I got to rebuild like all these data pipes. It's, oh, I already have this app. Just go point it to, the data lake and then go point it
yeah,
to whatever cluster. And you can just you can clone your tasks. The other thing, I guess, in tasks that makes it a little bit easier. Hold on, I'll get to this in a minute. So if I go in here, you kind of get tracking on like execution histories. We have the notion of long-lived tasks, but those are things for like polling, right, or receiving kind of like messages. But you kind of have like version control, so you can see like these are all the times that I did a demo for somebody and printed out hello world to them. So that's one thing. And then the other notion is that we also have an SDK for managing and updating tasks. And so just like Airflow is kind of built around code, we actually trigger a lot of our deployments for this system via GitLab. And so it'll actually run the tests for the apps, it'll deploy it, and then people actually can configure their tasks in apps. And so one of the example use cases is we have a data infrastructure team that has a project for core data infrastructure stuff, and then the different analytics teams kind of branch off of that. Well, those analytics teams have access to their projects. They do stuff in the UI because they aren't bothered to deal with like Git and manage code. But they kind of get version control for all their stuff because we keep track of versions. They're SOX compliant. But then that data infrastructure team has locked down their project. You can't edit it in the UI. So it's kind of like in Amazon when you're doing things via CloudFormation. Someone can still go in and like F up your CloudFormation templates, and then you got to like tear everything down and bring it back up. In this, you can actually create like blocked off, projects that are running that are only updated with code, but then the other people in your company can kind of collaborate and still work with that by triggering things or running tasks kind of dependent on those core tasks.
oh, yeah, it's pretty cool. Thank you.
What about security? Like, what things about security that you can give that usually take a lot of time to develop?
So building role-based authentication systems like IAM and other things. So in the permissions, you can actually create, pretty robust groups. And so the way that we get that locked down permission set is we create the different projects. Within the projects, there's different groups, and different groups have different access to different projects. And so typically what most people do is they have a read-only group that everybody has access to. You can see everything except for credentials across projects. But maybe there's an executor, and you have access to execute tasks, but you don't have access to edit them. And there's editors, and then there's like admins, that have the ability to create connections and things like that. And so building that and making sure that's solid was actually pretty challenging for us.
Okay. And you said that the applications can be of different languages, not necessarily Python?
Yeah, so when we go back to this model that kind of gets generated, it's YAML, but what it's saying is you are going to pass JSON blob, you're going to make a request to the platform for your execution instance. What are the parameters and credentials? And so in this case, what I'm saying is, if someone's going to create an instance of me, these are the parameters that I need to run. And so we have different types of parameters. So we have code blocks, strings, other things, but there's also things like Google tokens, Slack tokens, database connection information, and that gets passed in real time. I think in the Kubernetes world, there's a lot of environment variables that pass credentials around, well, depending on what people are using. And this is all done purely on API calls and stored in memory, so we're not storing anything to disk. If someone tries to hit the container underneath the hood or has access to that, but essentially our goal is to say, great, if everything is just API calls, I can be running Java, hit the API, grab some parameters, and then run my function with those parameters. And there's nothing stopping people from writing it in Java or anything else. It's just that we started with Python, building an easy way for people to generate this YAML file, because after working with Helm and Docker or Kubernetes, I was like, man, I really don't like Helm charts these days. YAML files, I'm just like, it's so much nicer to have like autocomplete and all that other stuff. So.
Yeah, I see what you're saying. I don't see any more questions, so yeah, I see people like your project. This is good. And I would like to ask if you want to tell something else about that we haven't asked or something. Otherwise, we'll open up for questions for both presentations, or.
No, I think that was it. Just sharing the Python code, running tests, decorators. I mean, it feels like you guys know Python pretty good, and this was built around Python, so.
Yeah, decorators are great. I agree. So now let's hypothesize, and this is just for the game. There are multiple people here who work in Austin who can actually, maybe there's a way that they can see everything. So and kind of link this together. So for example, Evelyn also, he has an on home automation, and Rakshak before, he showed his application for cameras. Let's say if you were to tie this to your app, what possibilities are possible? Like home automation, cameras, and num together. It's free for all. All of you can answer. Rakshak probably has problems in the microphone, so maybe you should start.
Can you hear me?
Yeah.
Yeah, I heard my name, but someone was blowing up my phone. Can you please ask me the question again?
So, the question I was asking is that NUM has showed a system that can integrate elements. Let's say you have an app that can run on NumNum, and what does NumNum can do that, for example, can automate your app and perhaps connect it to Evelyn, who does home automation. So I'm bringing you free, but like, because I know some of the things you're doing, but how do you kind of integrate those things together? It's just a play, so people will understand better how things work together.
Yeah. Hey, Nam, can you give me a like 30-second elevator pitch as to what your product does.
We help code become more usable to non-coders.
Oh, like to an engineer, not to an investor. Sorry.
Yeah. So the core problem for like back-end data engineers is they work for companies. There's typically handfuls of people using their code.
Mhm.
Their code is potentially applicable across the world, and
Okay.
they're just not tapping into that.
Oh, okay, got it. So they can build like some data processing functionality, but they can't really deploy it anywhere outside of like their desktop or something.
Right, or within their company, right?
Or within their.
And they typically built that process. And so,
Oh man,
you know,
there's so many places where that could be used.
But specifically within your application, let's say you create a camera that does the images and you need to transmit them and process them.
Yeah, so okay, that's a good question. So one thing that we do right now in the cloud that I think this could be used for is when the camera uploads the data, it's just gonna upload like, you know, men in this age. There were like 5 men in this age range, or there was this average sentiment here or there, right? So that gets thrown into our database, and then we have some extra code that's running outside of the database. So it like pulls from the database and then has to do all this data processing and create it in a different structure. So there's like some middleware that we have to write, and then that ships out to the browser. So the browser requests something. So basically, there's a mismatch between the data, both the format and what's expected from the camera, and what the browser needs to visualize, right? So if we have something like this, we could package a running thing, and like usually web developers are not data scientists and vice versa. So you could have a data scientist write the middleware in Python, you know, taking in the data structure and then exporting it as like JSON or something. So that's what I would use it for.
The other thing that you may not want to use it for is you mentioned your initial process that spits out, you know, all the data, age, number of people, all that other stuff. That could actually be packaged as an app that someone's saying, hey, here's my app. I'm going to pass in a path, which is a file to a video. Can you run Zenus's algorithm on it and give me the raw sentiment data out of it?
Yeah, I mean, you could package as a whole pipeline. Like you know, the stuff that's running on the camera, I could run it on my laptop or on a server.
Yeah,
So
exactly.
you could have, I mean, yeah. So like, you know that example I gave about the dash cameras. If we
Yep.
were just shipping like not a bunch of dash cameras, but if we were just saying, hey, if there's a client, and let's say they just really quickly want to see how accurate or whatever it is, usually the best way to show them is with a demo. We could tell them, hey, you know, take your phone, record some video, and then we could have something in the cloud like this that's just processing like little bits of video that they might record with the phone instead of like a really high resolution camera for a long time. And so this could be like its own kind of sub part of our infrastructure that's just processing these little requests from clients. It's not part of the production pipeline, right? But you could have one of these containers there. You could have another container in the actual production pipeline doing the data wrangling to fit it for the cameras too.
And the other thing about, you know, packaging your code is, you know, I think today a lot of people are just like, oh yeah, Jacob, you may not be a data expert, but you know Python, so you obviously know data. So go build some like enterprise grade Python stuff. And there's obviously a lot of like considerations that people that are really experienced can build into their apps that I think a lot of maybe novice people in certain areas don't take into account. And so we actually, for the founder of Bokeh, Brian, we built a CloudFront to Parquet parser that just takes like all of his CloudFront data for the Bokeh website, converts it into Parquet, which is something he's a lot more familiar with, and it does all the edge case stuff around reprocessing, handling bad files, and then tracking and automating like the continued process and keeping all that up to date while stripping PII information for him. And he pays $50 a month for that app. And you're just like, how many people out there are, you know, kind of data scientists that are like, oh man, I need to convert this CSV into Parquet since I'm dealing with like tons of data and I don't have to like keep track and manage all
You
these things.
basically ship them like a command line type application that they can use in their workflow. Is that what you're saying?
So yeah, I think that'll probably be a later on down the road thing for us. And I think if that was the core audience, like developers helping developers, I think open source already solves that problem.
So if you go on GitHub and you look at the issues for a lot of different projects, there's always a bunch of beginner questions like, hey, how do I get started using this? And it's after they look at their repo with the README and with the install instructions, right? So there's like, are there a group of people that can just use like Docker, right? And but they don't necessarily know how to use CMake, or they don't know how to build their own Python wheel, that kind of stuff, right? So or if you have like a really complicated setup, and you want to do some heavy data processing, you probably need some, like CUDA, or not CUDA, sorry, NVIDIA containers are like so nice, right? Because you can just package the whole runtime. So you can kind of leverage those pre-existing resources and then hand it to someone who a lot of times I would use something like this, not because I don't understand it, but just because I don't want to do it, right? Like,
yes.
Yeah.
Which, yeah, that was, I'm sure Brian, the founder of Bouquet, could have written that if he had spent the time. He just didn't want to have to deal with it. And for the price, it was kind of like a no-brainer to him. When you talk about like how companies decide on what pet projects to build, the meetings for those things are thousands of dollars with like all these VPs and senior engineers and trying to figure out like, what are we going to do? Like one meeting is worth more than the subscription of an app that may solve their problem immediately.
Yeah, I mean that's assuming they've gone through the build versus buy debate and they've chosen to buy.
Yeah, well, and when you're talking about that, part of that build versus buy debate is because it's either build or buy.
Yeah, I guess this could be used in both cases.
Right. That's exactly like one of the problems that we felt like exists is I'm either going to buy something that's 6 figures, or I'm going to spend the money to hire data engineers or backend engineers to build something, starting from an open source project.
Ooh, this is a random idea. What about for job interviews? So you have a person who's a data scientist, and they can get, let's assume they can get it working on their computer, right? So it's like a whatever setup they have. They have some algorithm or some process they wrote. So like when I say interview, I don't mean necessarily just for like a W-2 job, but also for like a contract or something. Mm-hmm. So maybe they could use this to package something that works, that some algorithm they wrote for that client, or some approximation of it, and the client can run it on their own data.
Yeah.
Without, because maybe the client doesn't want to give the data to the developer to run. Right. So it's similar. I got the idea because it's similar to what we were doing with the dash cameras. Like the data was not allowed to exit the UK, or I should say the EU at that time. Right. This is like right before they left the EU, I think. So the data was not supposed to leave the EU. All of our engineers are in America. So there's cases where the data just can't physically leave something, as an example. So you might have like a data scientist in company in London. London company has some secret financial data or government data. Just like in our case, it was a government event. There's a data scientist who could set up that Docker container using nom or whatever. So the data scientist at company A is helping sell company's A product to company B in London, but there are restrictions, and these restrictions are increasing with time. Right. We not too long ago, 10 years ago, you could spin up something in Virginia and serve the whole world. That doesn't exist anymore for a lot of cases, especially like the stuff that we've been working with biometrics. It just doesn't work. So there's probably so many cases where the data can't leave, so you have to ship the code. Oh, but then how do you make it one easy to do, and then also maybe you can work on like obfuscation or something if that was important.
Oh yeah, you have some good ideas here.
Yeah.
Yeah, I would say along those lines, a lot of people have written backend apps that like go out and clean up PII information from data sets and systems. You know, the minutia
exactly.
around doing all that stuff is like not something I wish for every data engineer and every company to
Yeah,
really
exactly. That's a great one. So they could give like the client could give example data that has fake names or whatever, and then they build the algorithm and the software around it. In let's say it's in a different company or different country, different territory, whatever, and then they can just ship that package over and throw on the real data.
Yep.
So that they don't have to do like a homomorphic encryption or something. I've tried. It's not fun.
Do you certify any of those apps, kind of like Google, like saying, hey, this app is safe, or do you go through any certification process or anything like that? Like, let's
Oh
say I'm
yeah.
building it. Yeah.
We do a pretty heavy code review since everybody's writing in Python with us right now, and it's I think eventually we'll have a third-party service that does the certification, just like Play Protect or whatever other services those companies use. But for right now, it's us like doing code reviews with those people, and the Python is easy enough to read for us as well.
Cool. Nice.
Okay. Any more questions to both speakers? Going once? Going twice? I don't see anything in the chat. And yes, thank you, Nam, for showing us more information. Please contact both speakers if you have any more questions. And since I see no more questions, I'm gonna stop the recording. Please stick around. We're not going away. Some of us want to stay late night here. So thank you all and stick around.